to the part 2 of steel beam design. In this video we are going to learn about uh, laterally supported and laterally unsupported beams, and how does it affect their moment carrying capacity, right? So usually when we talk about laterally supported beams, what does it come to our mind? That the beam would be like straight initially, it will stay straight laterally throughout its lifespan, right? So something will be keeping the beam in its own axis, in its major axis. No moment, no twisting or turning like this happen, should happen, right? It should not happen. So those kind of beam we consider as laterally supported beam. All right. So then which beams should we say laterally unsupported? Let's see. If you look closely here, right, there are many cases where the beam can deflect horizontally, right, like this, or maybe like this. In this case as well, lateral deflection may occur. So twisting may be there. So in many ways the beam can, since it's a steel member, the beam can buckle. The if there is nothing to keep it in place, nothing to support it, then it will definitely buckle, right, about its major axis, that is the longitudinal one. So in those cases we have to find out the moment carrying capacity considering the beam as laterally unsupported beam. So why should we consider different for these cases, like for laterally supported and unsupported? Because when something is in its own place, symmetrically in its own place, then the moment carrying capacity will be under ideal condition, right? But if it's moving, it's buckling, it's moving out of place, then obviously its moment carrying capacity is reduced due to that lateral buckling, right? So let's see, IS 800 2007 has provided the guidance to find moment carrying capacity for both laterally supported and laterally unsupported beam. So if you come to page number 52, you'll see a whole section dedicated to members subjected to bending, which is in our case obviously it applies to it beams, right? So here at clause number 8.2.1 you will find laterally supported beam. So due to paucity of time I would not just go through all of these things. I'd recommend you to read it, it's a good habit. So for a laterally supported beam, this is the particular expression that you need to use to find moment carrying capacity for laterally supported beams, the beams which are laterally supported, right? So here let's read it out. To avoid irreversible deformation under serviceability loads, MD shall be less than, so there is a clause given as well that this value that you are calculating, it should be less than 1.2 ZeFy divided by gamma m0 in case of simply supported, and another expression in case of cantilever beams. So whenever you are calculating this, make sure you calculate these values in your case, whichever it is, and it should be less than this. This value should be less than this one. And why is that? It's because to make sure that under the working load conditions, the beam does not go into yielding, right? So to make sure that this clause is applied here. Okay. There is also a case of high shear, low shear. In case of high shear, we have to use a different formula as well. That will come to in a later video. But this expression is applied for laterally supported beams in low shear conditions. Okay, low shear means a shear value of 0.6 V. 0.6 V. V is the shear force obviously. So it's written here when the factor design shear force does not exceed 0.6 VD, right? So low shear case and laterally supported, you have to use this formula. All right. Now coming to laterally unsupported beams, go to the next page. You'll find clause number 8.2.2, which defines laterally unsupported beams. Here some clauses are given. Okay, where how can you differentiate between laterally supported and unsupported beams? So if you just read out, bending is about minor axis of the section. So in this clause, whatever is written, if your beam satisfies these clauses, then your beam should be treated as laterally supported beam. If it does not, then it's a laterally unsupported beam. So if you're having bending about minor axis of the beam, then obviously your beam is laterally supported beam. The section is hollow or solid bar. In that case, the beam is laterally supported beam. In case of major axis bending, lambda LT is less than 0.4. So the question is, what is lambda LT? The expression is just given here. If you find this expression, then you get lambda LT. So it's a good habit whenever you're starting a problem. If it's not given in the problem that it's laterally supported or unsupported, if it's not given, you follow this procedure that and then find out whether your beam is laterally supported or unsupported beam. All right. So here the expression is given for moment, how to calculate the moment in case of laterally unsupported beam. So it's a long procedure that, like, you have to calculate like upside down. Like, you have to start this way. Start by finding this formula. Sorry, excuse me. Start by finding MCR. What is MCR? MCR is given as elastic critical moment as calculated here. So first calculate MCR, then calculate FCR. Just hang on a second. Okay, so this expression, it is given for symmetric cross sections, right? And this one is for standard prismatic members made of standard roll I sections or welded doubly symmetric I sections. So whatever is applicable in your case, you'll be applying this formula. If it's a prismatic section, you will be applying this one. If it's I section, you will be applying this one. So after finding MCR, you find lambda LT. From lambda LT, you get phi LT, and you have to have certain constants here like alpha LT. These values are given, like if it's a rolled steel section, then 0.21, if it's a welded section, 0.49. So these are empirical formulas that have been previously studied and discussed and then incorporated into the code. Okay, so then you find out xi LT. From there you calculate FBD, which is design bending compressive stress, and from there, if you just put it everything together here, you obtain the moment carrying capacity of laterally unsupported beams, right? So this is all about how to calculate moment carrying capacity. In the next video, we'll be discussing about shear strength, how to calculate shear strength, and obviously low shear and high shear conditions. Okay.